Hello friends, welcome once again to ASMNOFO online math class. In this video, I'm going to continue with my works on mappings, and this time around we are talking about a composite function, okay, or a composite mapping per se. For example, if you have, so this is f is a function where a is mapped into b, and g is a function where b is mapped into c. So let's assume that the image of A is E, the image of B is G, the image of C is F, and the image of D is H. And from here, the image of E is, let's say, K, the image of G is I, the image of F is J, and the image of H is K, for instance. So this is a mapping. This type of mapping, you see that A is mapped into B and B is mapped into C. This is a composite mapping. Okay, you can see that the image of the domain is now, or the image of the domain is now the domain of this particular map, of this particular set C. You notice here that this is the domain and this is the codomain, and all these elements here are the image here, or the range. Then you see that the codomain of this particular map A, or this particular set A, is the domain of this particular set. In a situation like this, we say that this is a composite mapping because A is a function of B and B is a function of C. Okay, now let us now provide solution to this particular problem at hand. In question number 1, we are asked to calculate the meaning of or the value of golf. First of all, the question says that let the mappings of f and g on the set of real numbers be defined by f of x is equal to 2x squared minus 3 and g of x equal to x plus 1, that we should find golf and fog. Golf is the same thing as g of f of x. Okay, g of f of x. Okay, so g of f of x, that means you should have known that f of x is the same thing as 2x squared minus 3. So you can call it g of 2x squared minus 3. That is the mean of f of x. So your f of x is 2x squared minus 3. This thing means you bring in your g of x. Already, our g of x is x plus 1, given g of x is plus x plus 1. So anywhere you see x in g of x, plug into x squared minus 3, because x is the same thing as 2x squared minus 3. So this is now g of f of x will now give us, look at x here, I'll put 2x squared minus 3. All these things here are serving for this x, then plus 1. When you do that, you will get 2x squared minus 3 plus 1 will give us minus 2. And this is the answer. If you like, you can factor out 2. Then for the second one, where we have the fog. The fog is something as f of g of x. F of g of x. So you have to get g of x first. So that will be f of, what is g of x? G of x is x plus 1, x plus 1. So you have to first of all get your f of x. Our f of x is 2x squared minus 3. So from here, anywhere I see x, I will put in x plus 1 in this function. So that will be 2 bracket x plus 1, then all squared, there is a power of 2 minus 3. So we are going to open this bracket here. Normally, when you have x plus 1 squared, it is the same thing as x plus 1 times x plus 1. X times x is x squared, plus x times 1 is x, plus 1 times x is x, and 1 times 1 is 1. So that will give us x squared plus x is 2x plus 1. This is what it will give us. So coming here, I'll just use x squared plus 2x plus 1 to replace this. So we shall have that fog is will now be 2 bracket x squared plus 2x plus 1, then minus 3. Open your bracket, 2 times x squared is 2x squared. 2 times 2x will give us 4x, and 2 times 1 will give us 2, then minus 3. So finally, the fog which we are asked to get will now be 2x squared plus 4x. 2 minus 3 will give us minus 1. So this is the solution to this particular problem. Expect my next video on steady composite mapping, because there are so many areas of the composite mapping. Thank you for viewing, and may God bless you.